So we want to do a few more examples of graphing piecewise functions, just to get the practice, get the experience here. Let's focus on this first piece. I'll call this first one blue. The second one I'll call red. And the third one I'll call, I don't know, green. So I'm going to look at the blue piece first. I already got my XY coordinate plane drawn out. So let's look at blue. Y equals 4 minus 2x. That happens when x is less than negative 2. So tell me about y equals 4 minus 2x. Well, that's going to be a line, right? We can rewrite that as y equals negative 2x plus 4. Right? That's called the y equals mx plus b form, or the slope-intercept form. So the minus 2, that dude is the slope. We call that the m, right? M is minus 2. And the y-intercept is what we often call the b, right? That's the plus 4. So if I wanted to graph this, what I'd do, I'd start at, with a very light pencil, the y-intercept, the 4. And I would go down to right 1, right? Slope of negative 2 is down to right 1. Down to right 1. Down to right 1. Down to right 1. Or I could go, also think about it this way. I could write it as 2 on top. Try that again. 2 on top, negative 1 on bottom. That would be up to left 1. So up to left 1, up to left 1, up to left 1, up to left 1, so on. And if I were to connect these very lightly with a very light pencil, let's pretend that's my light pencil there. Ooh, I got some stray dots here. That's what my line would look like. Now, the question is where we're going to keep the line. Where are we going to keep the line, guys? Well, here a restriction is when x is less than negative 2. Right? When x is less than negative 2. So I'm going to find negative 2 here on the x-axis, and then find my graph there, my blue graph. Well, that's like here, right? And less than negative 2 means to the left. So we're going to graph the line up here. Now, at negative 2, I'm actually going to put an open circle there. There's actually going to be an open circle here. Well, goodness gracious, this thing is just falling apart. Why does it do that? So we had this bit of line here going up and to the left, and then we have an open circle when x is negative 2 on the graph. Okay, let's get rid of the rest. Let's get rid of all this other blue stuff. I can't really get rid of that, can I? Okay, let's just pretend, come on now. Let's pretend that's black. Come on now. This dude is not nice. There we go. Just make that a black mark. All right, so we have our blue piece of line going up there in the left. Now let's go to y equals x squared. That's the red piece. I get it to right. Y equals x squared. That's the red piece. And that happens between negative 2 and 1. So remember the squaring function. You have 0, 0 as a key point, 1, 1 as a key point, 2, 4 as a key point. What else do you have? You have negative 1, 1 is a key point, and negative 2, 4 is a key point. Okay, and if you were to connect these very lightly, you would get something like this. But we are only going to keep this parabola, this is what it's called, a parabola, this horseshoe-looking thing, between negative 2 and 4. So here I'm going to find negative 2 and 4. No, 1, negative 2 and 1. I misread that. That's not 4. Negative 2 and 1. So here's 1. So we're keeping the red between those boundaries. Okay, so we're going to get rid of everything here to the left of negative 2, and we're going to get rid of everything to the right of 1. Now, what are we going to do at negative 2? We're going to put a closed dot, right? A closed dot. We have a closed dot there at negative 2 because we're allowed to be equal to negative 2. And at 1, we're going to put an open dot for now because x is not allowed to be equal to 1 here with this red piece. All right, so we get rid of the markings, and we got our red piece. So we got the blue piece. I got some straight marks up there. We have the red piece, and now we're going to do the green piece. Y equals 1 over x, and this happens when x is greater than or equal to 1. So remember, this is the reciprocal function, y equals 1 over x. The reciprocal function, you have key points of like 1, 1, 1/2, 2, 2, 1/2, and it does something like this. And also you have key points at negative 1, negative 1, negative 2, negative 1/2, 1/2, negative 2, negative 1/2, negative 2, and you get something like this. Now the question is, where do we keep this green reciprocal function? Well, when x is greater than or equal to 1. So where's 1 on the x? It's right there. So we're going to go up and find our graph. So we're going to keep this to the right. That means we're going to get rid of all the green markings to the left of 1. So let's get rid of all this here. Let's get rid of all these markings here. All right, so I scratched out some stuff. Let's go back and put in my numbers. 5, 4, 3, 2, 1, negative 1, negative 2, negative 3. Okay, now the final question is, what do we do when x is 1? When x is 1, do we keep it an open circle or a closed circle? We're going to fill this one in, right? We're going to fill in that. So we had an open circle that was red. Now we're going to fill that in with the green circle. A closed circle. There we have it. So we have this blue piece of line. Blue piece of line. Can't get this to right. There we go. Blue piece of line. We have this red piece of parabola, and then we have this green piece of reciprocal function. And if you want, you can make a little dashed line down here. I'm going to make it purple along the x-axis to indicate the horizontal asymptote. So that green reciprocal function is going to go to the right forever. It's going to get closer and closer to the x-axis. So that x-axis is a horizontal asymptote. for the green. So you got 3 pieces. Notice that it's a broken function, right? It's disconnected. That's fine. That happens sometimes. Your graphs don't always have to be connected. So this would be called a discontinuous graph because it's disconnected. All right, we're going to do one more example. One more example for practice sake. Let's call this one K. It's going to have 3 pieces. X cubed, when x is less than 0. The square root of x, when x is between 0 and 9. And 12 minus x, when x is greater than or equal to 9. Call the first one blue, second one red, third one green. Let's see, how big do I need this? I need this one pretty big, I think. Okay, I don't know what happened there. I think this should be good. Okay, this one's going to have to be long, I think. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -1, -2, -3, -4, -5, -6, 7, and -8. All right, and then 1, 2, 3. I don't know, maybe this is not a good setup. Let's make it not so big. I'll have to change my scaling. I'll do these by 2s, as I'll say. I'll do them by 2. So I'll make this 2, 4, 6, 8, 10, 12, 14. 1, no, this will be 2, 4, 6, 8, 10, 12, 14. This would be -2, -4, -6, -8, -10, -12. And then on the other side, I'll have -2, -4, -6, -8, -10, -12. And I've forgotten my functions. Okay. The first one's going to be y equals x cubed. That's when x is less than 0. So that's the cubing function, So we're going to have points at 0, 0, 1, 1. Oh, where's 1, 1? 1, 1 would be like right here, and then at 2, 8, that would be here. We're also going to have points at -1, -1, and points point at -2, -8. And this is sometimes called the bodybuilder function. So we're going to keep this only when x is less than 0, right? This tells us right here when x is less than 0. So where's 0? 0 is right here. So we're going to keep this to the left. To the left of 0. So that means I'm going to get rid of all this other blue stuff to the right of 0. And at 0, I'm going to have an open circle. Why an open circle? Because x is just less than 0, not allowed to be equal to 0. So I'm going to have open circle there. Terrible. All right, so I got my blue piece. Oh, we want to do the red piece. Y equals the square root of x. That's when x is between 0 and 9. Allowed to include 0, not allowed to include 9. So the square root function has points of 0, 0, 1, 1, 4, 2, 9, 3. Yeah, and it looks something like this. So the square root function here, we're only going to keep it between 0 and 9. So where's 0? 0 would be here, and 9 would be like right here, right? Since I'm going by 2s, you can't see 9, but it's halfway between 8 and 10. So I'm gonna keep this from 0 to 9 within this window. I'm gonna get rid of everything to the right of 9 here. And at 0, I'm going to fill that in with a closed circle. Why? Because x is allowed to be 0 for this red piece. All right, so we got the blue piece. We have the red piece. Finally, we want to do this green piece. Y equals 12 minus x when x is greater than or equal to 9. So if I rewrite this, this is going to be y equals minus 1x plus 12, right? 12 minus x is the same thing as minus 1x plus 12. Minus 1 is the slope, so the slope is minus 1, and the y-intercept here, b, is positive 12. So to graph this in green, I'm going to find positive 12 here on the y-axis. I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So down 1, right 1, 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 down 1, right 1. If I connect this all together very lightly with a dashed line, I'd end up getting something like this. Okay? And the question is, where do I keep this dude? Come on. Where do I keep this green line? Well, it says when x is greater than or equal to 9. So I'm going to find 9. Where's 9? It's right here. Right? It's halfway between 8 and 9. I'm going to go find where the green graph is. It will be right here. I'm going to shade to the right of 9. That means everywhere to the left of 9 I have to get rid of. Everything in green, that is. Okay, how about at 9? the green graph at 9. I'm going to fill that in, right? That's going to be a closed dot. So we previously had an open circle here at 9 in red, and we're going to fill that in with a closed circle. Because x is allowed to be equal to 9 with the green. So yeah, that's your final graph. You have this blue bit here. You have this red bit, and then you have this green bit, and they all do connect.